Ever wonder how your music app just knows the next song you want to hear, or how a chatbot actually understands what you're asking instead of just matching keywords? Well, the secret isn't magic. It's this incredible hidden technology that works like a memory for AI. And today, we're going to pull back the curtain on vector databases.
Okay, so let's just get right to it. For all their amazing power, a lot of AIs, especially the big language models, have a serious memory problem. I mean, they can be brilliant one second and then completely forget a key piece of information the next. And that is the exact problem that vector databases were built to solve. So where does this memory problem come from? Well, it really boils down to how we've always stored data. Think about a normal database or even a spreadsheet. They're super organized, for sure, but they think in black and white. It's either a perfect match or it's not. And that rigid approach just doesn't fly in the super nuanced gray world that AI has to live in.
Yeah, just look at the difference here. On one side, you've got your traditional databases. They are absolute champs at storing simple stuff, text, numbers, and finding exact matches. You search for the word cat, you get results with the word cat. Simple, clean, done. But AI needs more, right? It needs to understand relationships. It needs to search for similar ideas. Is feline related to cat? Is a kitten? An old school database would just say no. And that's where things start to fall apart.
So to solve this, we needed a whole new approach, a new type of database built from the ground up, not just to store data, but to understand and store its meaning.
And the secret ingredient is something called a vector. The best way to think about it is like a universal translator for AI. It can take literally anything, a sentence, a photo, a song, and turn it into a long list of numbers. But this isn't just a random list. It's a kind of numerical fingerprint. It captures the essence, the context, the vibe of that thing in a mathematical way so that similar concepts end up with similar fingerprints. And this quote just nails it. We're not talking about digital filing cabinets anymore. This is way, way bigger. What we're really doing is creating a form of computational memory. It's a place where an AI can stash complex ideas and then recall them later, not by searching for a specific word, but by finding a related memory.
Okay, so our AI now has this incredible bank of memories. How in the world does it find the right one when it needs it? Well, this is where the real magic happens. It's not about searching for words anymore. It's about finding things that are conceptually close.
And this brings us to its one true superpower, similarity search. It completely changes the game. Instead of asking, find me documents that say fast car, you can ask, find me things about high-performance vehicles. And you might get back results about sports cars, racing, maybe even supercars, even if the words fast car are nowhere to be found. It's searching for meaning, not just text.
And, the whole process is actually pretty cool and surprisingly simple. So first, you give it a query. Could be a sentence, could be a picture you upload, whatever. The system immediately turns your query into its own vector, its own unique numerical fingerprint. Then, it zips through the entire database and compares your query vector to every other vector in there, basically checking for closeness. And finally, boom, it returns a ranked list of the things that are most similar in meaning.
Now, I know this can sound a bit abstract, maybe a little sci-fi, but I promise you, you are already using this technology constantly, probably every single day, and you don't even know it. So let's look at where it's already working.
That online store that somehow recommends a product you instantly love, that's a vector database finding items with a similar conceptual vibe to stuff you've liked before. Or how about when you search your photos for beach and it finds pictures of sand and waves, even if you never tag them? Yep, that's vector search matching visual patterns. It's even starting to change healthcare, helping doctors find patients with similar medical profiles to create personalized treatments. And of course, it's the beating heart of modern chatbots, letting them understand what you mean, not just what you type.
But honestly, for all of these cool applications, the most powerful, most transformative use case is just getting started. And it involves pairing vector databases with the biggest brains in the AI world, large language models. Okay, think of this combo as giving a brilliant, incredibly creative, but kind of forgetful artist a perfect, searchable library for them to reference. LLMs are amazing, but we all know they can be factually, well, let's say, creative. They make things up. Vector databases are the grounding force they desperately need.
So, when you connect an LLM to a vector database, you're essentially giving it an external, long-term memory. But it's not just any memory. It's a trusted, fact-checked knowledge base that you control. So now the LLM can check its own work against a source of truth. This makes its answers way more accurate, way more reliable, and just better. It's the critical difference between an AI that's just guessing and an AI that actually knows.
Which really brings us to the big final question. Vector databases are so much more than a new way to store files. They are a fundamental building block for the next wave of artificial intelligence. They give our most powerful tools a memory that understands context, relationships, and meaning. So you have to ask yourself, what becomes possible when AI has a perfect, searchable memory? I think we're only just starting to find out.